Hi, my name is Leandro and today I'm going to talk about interaction design applied to Ubimus, but using musicality as a guideline. I would like to highlight three important concepts of this presentation. The first one is musicality, then interaction design, and of course Ubimus. I will discuss more about them later. We are interested in studying that because we belong to a network of research groups that study ubiquitous music, and among other things, ubiquitous music or Ubimus is regard to design musical things accessible and available even for non-musicians. And from our side, we do that by creating games, toys, and mainly artistic multimedia installations, which we believe is a great way to understand the interaction between the general public and a musical activity. Another project that we have been working on is the Robomus. It is basically a framework to build musical robots using spare parts and recycled parts by students from the computer science and computer engineering course. These robots can interact with each other and can also interact with a human musician, which we believe is a great umbrella project to understand more about how humans interact with robots in a transparent way. Another area linked to this idea is the Internet of Musical Things that explore new ways to engage into musical activities using these smart musical instruments. All in all, it is a matter of human-computer interaction, specifically interaction design. And our ultimate goal is actually to provide some guidelines to designers so they can create a more engaging musical instrument, digital musical instruments device. If you're not familiar with the term interaction design, it is basically the design of the interaction between users and products. In our case here we talk about digital products. In other words, digital things, or more specifically, musical things. It is concerned to aesthetics, motion, space, and sound. The goal of the interaction design is actually to create products that enable users to achieve their objectives in the best way as possible. And why it is important to talk about interaction design concerned to Ubimus or the design of digital things. It is because historically digital things made by interaction designers were basically tools. They were meant to solve problems, to carry out tasks, and to be used mostly by one person. So in that sense, talking about user goal, task flows, usability, utility, made sense. However, digital technology in today's society is basically used for communication and it is not so traditional anymore. Now we have many-to-many communication. We have to think about persist records to all the exchanges. And we talk about design things just for the sake of entertainment and pleasure. If we look at this picture based on the disciplines of the user experience by Dan Schaffer, we will see that interaction design overlaps many different areas, including ergonomics, informatics, psychology, and cognitive science. We can also observe that interaction design is within a bigger area called user experience design. User experience, as its name suggests, is about designing the ideal experience of using a service or a product. You don't design the user experience, you design for the user experience. It is about how a product behaves when it's used by people, real people, in the real world. It is about how people feel the product, their pleasure and satisfaction when using, looking, holding, opening, closing, manipulating the object in general. Every product has a user experience. Doesn't need to be digital. Can be newspaper, ketchup, reclining armchairs, whatever. One of the main methodologies to designed for the user experience is the user-centered design, or the human-centered design as I prefer. The idea is to design with the user needs and expect behavior in mind, so we need to understand our users. And we do that by taking into account what people are good and bad at. And this includes cognitive and motor limitations. We need to consider also what might help people in the way they currently do things. We need to listen to them, get them involved. So, in summary, musicians should be involved in the design of musical things. As previously seen, there are many layers that we can and areas that we can use to better understand our users. We can understand our users ergonomically wise, cognitively wise, or combining both what has been called human factors. Before the birth of the human factors or ergonomics, emphasis was placed on designing the human to fit the machine and not the other way around. And this is still very true when you talk about musical instruments, even digital musical instruments. There has been a duality between the terms of human factors and ergonomics. They have even been used as synonyms. However, ergonomics is more related to the interaction between the human and the artifacts. We talk about here physical aspects of the workplace and the human abilities to perform that task. Not cognitive abilities, more physical abilities. Human factors, on the other hand, also known as cognitive ergonomics, studies how humans accomplish a work-related task in the context of a human-machine system operation, and also concerns about behavioral and non-behavioral variables that can affect that accomplishment, right? So it is linked to decision-making process, organization design, human perception as well. So that it is where cognitive science comes into the play, right? Cognitive science uh, is the scientific study of the human mind. So usually we study cognitive aspects such as language, perception, memory, attention, reasoning, and emotion. The goal of cognitive science is to characterize the nature of the human knowledge, forms and content, and how that knowledge it is acquired, processed, and used. So based on that, we decided to study more about the origins of the music, the underlying mechanisms that allow us to perceive and produce music. And this has been called musicality. It has been defined as a natural, spontaneously developing set of traits based and constrained by our cognitive and biological system. Music itself is just a product of musicality for this purpose. However, this notion of musicality has been a bit controversial. Most scholars were very of the notion that music cognition could have a biological basis. They believe that we have not been around long enough to have shaped perceptual mechanisms specific for music. This is different when we think about speech and language. Nevertheless, more recent studies has indicated otherwise. What can be agreed on is that all humans share a predisposition for music, in the same way that we have for language. For example, recognize a melody or to perceive the beat of music. These are examples of traits based on and constrained by our cognitive abilities and the underlying biology. Even infants, they are sensitive to such features, and that is common across different cultures. Even people who consider themselves in music, they have an implicit knowledge of musical forms and styles of their particular culture. If you think about it, we can find music in all cultures and all time periods, and these say something. And it becomes even more interesting when we realize that some of the fundamental mechanisms that underlie human musicality are shared with other species. For example, the drumming behavior of our nearest relatives, the chimpanzees, or the commonalities of a bird and whale song. It is out of the scope of this presentation to go deeper into this particular uh, matter, but recent advances in molecular technologies has been proving that. Now let us consider what happened with the computer market in the 1970s. Up to then, only professionals and dedicated hobbyists were able to deal with computers, right? But with the emergence of personal computing, everyone became a potential computer user. So the companies that produce computers realized that there were a usability issue, and if they want to boost the sales, they had to improve the technology so everyone could use it. So this was basically the birth of the human-computer interaction, and the road that they have decided to take was applying the knowledge of the cognitive science into the design of the new computer technology, something called cognitive engineering. In the late 60s and 70s, the first synthesizers start to be commercialized as well, right? So we see like the Moog here. It's a design that was inspired by the piano, a piano interface with the keys, and the electronics of the time with knobs and faders and cables. But that was the 60s, right? Of course, it required a lot of technical knowledge to operate and deal with this machine. Not rarely you see technical guys uh, turning themselves into musicians because musicians were not able to master that technology immediately. But they eventually did, right? And that design became kind of a classic. But it's the best that we can do. I mean, the computer design have evolved a lot since then. But it seems that the design for synthesizer or other uh, musical things has been stuck in time. For example, this is the design of a modern synthesizer, and except from the cables, all the knobs, faders, and the piano keys are there with some probably new inputs, but it's still something very technical. I mean, interaction-wise, it is pretty much the same. I believe it is even more worrying when you see the same design applied to software. If you have a controller, then you're stuck with knobs and faders again. Otherwise, you have to use keyboards and a mouse to operate knobs, cables, and faders. It simply doesn't make sense. We have to rethink that, right? We have to once again look to the musician and design new technology, not just copy technology from the 60s. So, in order to propose new technology, or at least new ways to interact with musical technology, we have decided to study more about the cognitive aspects of the music and the underlying biology that support that cognitive traits used for music. And this is what we called the musicality oriented interactive design. We have a group that we don't have time to go through every single one of the cognitive trait that we have been studied, but we group them into 5 different categories. The first one is about materiality. We're going to talk more about this in a bit. The second one is about the rewarding state of consciousness, of that basically is the pleasure of making music, learning music, and and engage into musical activity. We have also traits linked to gesture and movements, how these natural mappings occur and how we perceive them. Also traits regard to entrainment, synchronization, and beat perception. And last but not the least, the imitative behavior. There is something very, very strong in infants. It is the base of our learning experience. So it's about how we learn music, how we learn to play a musical instrument, so on and so forth. So as a case of study, let's talk about materiality, for instance. All the rest of the groups you can find at the paper, but for now, with the time that we have, let's discuss more about materiality. So striking objects with our limbs or any other body part, or objects, for instance, the drumming, constitutes a core component of the human musicality. So this is the trait. This is something that we are all humans are very good at doing. We also know that digital instruments, they lack the relation between the physical and the digital representation. So it seems to be less of an embodied practice than, for instance, playing an acoustic instrument, especially because when you play a digital instrument, you can change very easily how things are done. A variable, a setting, a patch, a program. So you don't have time to establish a motor memory action and its consequence. We also know that due to their materiality, acoustic instruments, they limit the sound scope of the instrument. This means that the interface are simpler to understand. There are a natural mapping between the exertion of bodily energy and the resulting sound. So this could be in form of plucking a string or hitting a drum. It's not about only the audible feedback, it's also about the haptic feedback. So we are good at playing instruments in this way. We have evolved at playing instruments in this way. That's very different from hitting a button and waiting some processing, time lapse, and then there's a sound. We don't shape the sound with our own hands, as we do with the acoustic instruments. There is a big part of the user experience that is regard to avoiding or trying to avoid the frustration of the user. And when we talk about acoustic instruments, there is a quality to it that is the durability, the perennity of it. Acoustic instruments do not have a due date. It won't get updated if a new operational system comes out. It's different from software synthesizer that requires updates, fixing, and other issues regard to compatibilities. There's an overall uncertainty about the continuation of the product. That's quite different from the acoustic instruments. Even if a guitar manufacturer decides not to sell a particular model anymore, another manufacturer can sell a similar one, and the interaction design, the skill that you have developed from the previous instrument can just be used in the new one. That's not the case with digital instruments. So considering all these aspects that we have discussed about materiality, we thought about some guidelines that someone could use to design new musical things. For instance, it is a good idea to invest in a durable design, something that uses good quality materials, something that will evoke desire in the user, not only the desire of engaging to musical activity, but also the desire to own that object, something that will favor the emotional connection between the user and the instrument. Not something toyish-like, right? Uh, when I mean something toyish-like, something that looks like a toy, something very disposable. The user should have the desire to spend time to master that instrument. That should be something challenging. In that way, maybe augmented instruments will be something that should be preferred. Also, we should think about limited number of the features that the instrument will offer to the user. If it is something too easy, of course, it will become boring. But if it's boring, but if it is something too difficult as well, this can, favors frustration. So we can limit in a way that the user thinks, okay, now I have control of the instruments, I can start to elaborate more my musical ideas and not spending a lot of time with the technical issues. Uh, we should also avoid the temptation of just copying the interface of the acoustic instruments in the new digital counterparts. Of course, something positive to incorporate familiar materials. We all know the sensation of a string vibrating in our fingertips, so that would be something desirable. We should also just copy the interface after some ergonomic studies, not to replicate the issue that acoustic instruments have regard to injuries. So that's it. I believe I used all the time that I had. Thanks for listening. If you have any questions or comments, please let me know. Write to me. I'll be more than glad to reply as soon as I can. Uh, Once again, I apologize for not being able to attend the conference in person, but I hope to see you all very soon. Bye bye.